Hello, Algebra 2 class. This is your lesson 94, dealing with dependent and independent variables as well as functions. We're going to start in our notes looking at the different types of functions and those that do not constitute as a function. So let's first take a look at the graphs and talk through this. You have learned about something called the vertical line test. In the vertical line test, you are taking a vertical device, you can use a ruler or a pencil, and you're just going to take that device, writing it from left to right along a graph to determine if there is more than one point being touched at a time. So when it comes to this first graph up here at the top, when I take my device left to right, I'm only hitting one spot at each time. And even in this crazy looking graph here, it is considered a function because it's never hitting more than one spot at a time. If you look on the not a function, right over here, all of these points would have been hit at the same time if we were going from left to right. It would have been actually an infinite number of points hit just right there on, it looks like x equals -5. So therefore it is not a function. The same is true over here. We're going to have top and bottom, two separate spots that are being hit at the same time if we take that vertical line test across. So you get an idea of using a graphic approach, whether something is a function or not a function. Okay, and then we're going to look at it algebraically as well. This is review from Algebra 1, so this should look familiar to you. First of all, we have the idea of an input value. Input values are your x values. Okay, so these are considered independent variables. If we're talking about science class and we are going to graph something on an XY table, independent variables usually deal with something like time. Okay, because they are not affected by what's happening in an experiment. You're just going to continue measuring time and then something else changes over that time. That something else that changes is your output. That's your dependent variable. So in the case of maybe a science experiment, you might be detecting how quickly something melts over a period of time. And so the dependent variable might be the mass of an ice cube. And that would change over a period of time, dependent on what that time is. All right. Now, as I'm looking down at the actual definition, this is critical for you to know what a definition of a function is. It is a mapping system that we have a domain and a range. That's your output. But I want to give you a better definition than that. Each domain element has exactly one range element. And that means this. Every x has exactly one y. All right, so if I look at this using a mapping diagram, that's using these examples down here, I can see a scenario here on the map number 1 where there is a shared element over here in the y values. The number 4 is being shared with both a 2 and a -2. This is allowed for it to still be a function. Okay, in fact, I can still picture my math teacher back in dinosaur days in high school telling us that that x value is like the girls situation and the y value is the boys. All right, so this is how the double standard works. Girls are not allowed to have more than one boyfriend. Boys, however, you can have as many girlfriends as you want according to the rules of functions. Okay, so if we assume girls to be the x values, they are allowed to date only one boy at a time, and therefore this does constitute as a function, ignoring the fact that the boy, number 4, has 2 girlfriends. That's okay, it is acceptable. If you look over on example 2, and we follow that same concept, you're going to see the troublemaker right away is girl number -2. She ended up having two boyfriends, number 1 and number 3. Okay, so this does not constitute a function because the x value can only have one y value that it's matched up to. Now you're going to have a chance to test your knowledge on the concepts of functions. Looking down here on figures 1, 2, 3, 4, you're going to determine yes or no, is this a function? Yes or no, is it a function? So you're looking at your x values and seeing, does each x value match up with one y value? All right, so for figure 1, I'm going to point out that we do have an x value paired up with two y values. So no, not a function on this one. Going to figure 2, it looks like everybody is playing nicely. Every x value has exactly one y value, so that is yes. On figure 3, every x value has one y value again. So yes, that's a function. And figure 4, it looks like we do have an x value that is double paired, and therefore this is no, not a function. All right, moving into the next portion of your packet, this is your ABC questions from your textbook. So you're going to want to have page 392 up and ready. And the types of questions that Saxon will ask you is essentially, these are some ordered pairs. Would this make a function, yes or no? All right, so for question A, he gives us a set of ordered pairs written as a list. And I'm going to show you this first one, how it's written out. And then I'm going to show you how you might benefit from rewriting it. So we have 5, 1, 4, 0, -3, -2, and then -4, 2. As I'm going about trying to figure out how many x values are paired up with exactly one y value, there are a couple ways I could do that. The first one I'm going to show you is just an xy table. So I'm going to make my traditional xy chart that you've used before. And I'm just going to take the values that were presented to us and list them in the order they were presented. 5, 1, 4, 0, -3, -2, -4, 2. And this might make it a little more organized for you to tell if there are any x's that were repeated. Okay, in this case, there are no x repeats, and therefore, yes, this is a function. So the solution that you would say here is function. All right, moving to question B. Once again, it's presented to you as a list. 1, 1, 2, -1, -5, 1, and then 3, 1. All right, so another way to look at this, if you don't want to do the XY table, is to just focus in on your X values and check if any of them are repeated. Okay, so if I'm looking through this and I find 1, 2, -5, and 3 are the different X values, there are no repeats of the X values. On a side note, you can see that there were repeated Y values. Okay, so Mr. Number 1 has definitely multiple girlfriends, but this is acceptable. So again, this is a function because there are no X values that were repeated. So function, all right, because once again, we can't repeat those X values. That is what constitutes it not being a function. Question C, ordered pairs are 1, -1, -1, -1, 6, -2, and 4, -2. And I'm going to show you one more mapping system just so you have a choice of different ways you can present this and figure out your answer. So I'm looking at my X values, putting them in a list. I have 1, -1, 6, 4. Oops, 6 just had some kind of an issue. Let's fix that. All right, and then my Y values that went with each of those, I'm just going to write them in the order. Oops, strike that. Pay attention here. In the order that we see them. All right, And a mapping system might show it more like arrows of who they are partnered to. Now you'll notice that -1 is being shared. So you'll also see mapping systems written like this, where they both are paired to -1, okay? And then we had 6 and 4 both sharing the partner -2. This is again acceptable. We are able to share on the Y side, we just can't share on the X side. So once again, yes, this is a function. We've had 3 in a row that are a function. Going to question D. Let me make our list here. We have 3, 2, 0, -2, 3, 0, -2, -2. And I'm going to focus in on my X values. Notice if any of those have been repeated, and we do have one that's repeated. The 3 gets repeated. So I need to highlight to see, is it repeated with a different number? And it is. One time 3 is paired with a 2, and one time it is paired with a 0. So in this case, it's not allowed for X to be shared that way. This is not a function. All right. Then the second part of our lesson here is about solving within a function. These are sometimes called like the plug and chug questions. I'm going to write down the original H function that reads H function of X equals 7X minus 2. And then we have a P function also provided. P function of X is equal to X squared minus 5X. The question that's presented is find P of -5. So that means the P function, plug in -5. Well, that means that we only had to focus in on one function from above. It is just like Saxon to give us 2 functions, but we only are going to use one function. So focus in on the P function, P of X equals X squared minus 5X. So for P of -5, it means wherever we originally saw an X, we're now going to plug in a -5. So on the right-hand side, where you see an X up here, you're going to now plug in a -5. Okay, so it would look like this. -5 plugged in, squared, -5, and then plug in -5. All right, I'll color coordinate that just in case that's helpful for you to see it. Now I'm going to go back and simplify that. Do not get caught up on what's on the left side of the equation. That can just stay. You can bring it straight down, or you can even just leave it and not write anything on the left side. We're really only focused on the right side of the equation while we're simplifying. So -5 squared is -5 times -5. That would become positive 25. And look here, we also have a -5 times a -5, so that would be plus 25. Okay, so my solution is 25 plus 25, which is 50, and that is all I have to have highlighted is my answer for that. All right, and then you are going to have some Delta math questions for this lesson. Good luck.